Program CICS 2 is a typical single record update, updating a record with this screen. The record is from a vsam file with primary key account and an alternate key on name. This definition is all that Jazz needs to generate our program. Jazz creates the COM area, screen, and program. And submits the screen assembly to create the BMS map. We could click Process now to compile our program, and it would be ready to run. We don't need to change a thing. In the COM area, function is correct, and the COM area already contains the record save area that pseudo-conversational programming requires. The screen looks okay too. The primary and alternate keys come first. The function code follows, and then the other fields are aligned vertically. Like Menu 1, Program CICS 2 accepts function and uses a case statement to handle the alternatives. Things start to get interesting here. Accept, account or name, and get cust_f key, account or name go together. If a value has been put into account, then we'll validate it and use it to look up cust_f. If not, we'll get the name value and use this to access the file. Name is not a unique key, so there might be several records returned by get. Our program needs a way of handling this. When multiple records are returned, all of their keys are stored in a temporary storage file, and logic is generated to read the previous next record from this list with PF10 and PF11. TS1 has been added to the get statement to relate it to a particular TS file, and a definition of the file has been inserted into the program. Save copy saves a copy of the record that we've just read, in case we want to update it. In the update logic, the get statement uses the saved record key to reread the record, and checks that nobody else has changed it since you read it the first time. If it survives this test, you accept data entered in the screen, and then update the record. To be safe, both add and delete are forced to follow an inquiry by using the same check copy logic. Let's review what just happened. We started by defining a record layout, 11 lines of Jazz, or 14 if we include this definition. Secondly, we generated the program, one form, at most 8 input fields, or choices that we needed to make. We clicked Finish and Jazz took over. First, it generated the COM area. Then it created the screen layout. Thirdly, it created a 19-line Jazz program, from which Jazz produced 1,421 lines of COBOL. This compiled to a pseudo-conversational update program, accessing the data by primary or alternate key, with built-in PF10, PF11 paging. Not bad. That's a productivity increase of more than 100 times. Click here to go on with the third video in the classical CICS series. There, we'll learn how to handle parent-child record sets, as in order entry. Or click here to learn about web service programming with Jazz. Or click one of these links to read about Jazz in more detail. Thank you for listening.